Our design approach was to use one media, activated carbon, to fulfill our stretch goal. We used activated carbon because we believed it was the best media to remove dye.
So for iteration 1, we lined the top of our water bottle with cheesecloth. From there, we then placed underneath it a coffee filter filled with activated carbon, and then we put a cotton ball underneath to catch additional dye. What we ended up finding out, however, was that when we placed the water into the system, the cheesecloth didn't catch nearly as much dye as we anticipated, and because we kind of made the water filter over to the sides, the activated carbon was missed by the water, and therefore dye extraction wasn't fulfilled as we were expecting.
For iteration 2, we decided to build our filter inside of the funnel, and we stuffed cotton balls in the bottom of the funnel to slow down the water and see if it could absorb any of the dye. We put carbon on top of the cotton balls and then cheesecloth on top of the carbon. We decided to use a funnel because it would condense all of the carbon inside of a small area to catch as much dye as possible. In this iteration, we realized cotton balls wouldn't work because they just absorb the dirty water and did not filter any of the dye out.
Okay, so for our third iteration, which was our final iteration, we reverted back to our original idea with the upside down water bottle as the housing. So we had the water bottle with rolled up cheesecloth stuffed into the bottom of it, and then we screwed the cap back on and poked holes in it so that the water would flow much better. And we poured the activated charcoal just right on top of the cheesecloth and packed it extremely tight. And so for this idea, it worked a lot better because the compacted activated charcoal, there were much smaller pores which trapped more of the dye, and the cheesecloth being rolled up really tight had the same effect. So that's why we stuck with this iteration.
So in terms of cost, we spent $202 of the $300, which placed us just above the 2/3 mark. When you break that down, we found that $40 of that was utilized for the water bottle, which served as our housing. We utilized 1 square foot of cardboard, which was $20. We used 3 activated carbon packets at $35 each for a total cost of $105. We also utilized a cheesecloth, which cost us $15, construction paper for aesthetic purposes at $2, and the use of general tools, which was $20.
So with more time to be able to improve our design, the first thing we would do was test more. With our first 2 iterations, we asked the TA if we needed to test, but he said because there was no noticeable difference in the water change that there was no need to test. And also with our final iteration, when we went to test it on the last day that we had, the spectrophotometer was not working, so we didn't get a chance to collect any valuable data. Also, with our final design, in order to keep the filter upright, we placed a piece of cardboard at the base. And although this was effective and extremely cost efficient, it wasn't at all aesthetically pleasing and could have been developed further to create a better design. And finally, our final iteration also included sand, just thinner sand in 3 layers of coffee filter, which filtered the dye extremely well because it was able to slow the water down before it hit the activated carbon. But that also eliminated our chances of fulfilling the stretch goal of 1 media, so we had to eliminate that. So with more time, we would include that and focus our time on developing a different stretch goal rather than 1 media and able to more effectively remove dye. As far as data goes, we were able to gather some data when creating the calibration curve as we measured the absorbance of different concentration levels of the dirty water. And so on test day, our percent dye removal was at 27%, so that leaves the concentration at around 0.75 for our water. And following the trend line created giving the calibration curve, the 0.75 concentration leaves us at about a 0.8 of an absorbance reading.